So this is the second video about differentiation, and this one we take the idea of differentiation a little bit further. Still haven't quite got to the crux of why we're doing it, but you know we'll get there soon enough. That will come up in the next video. So in this video I want to show two key skills. The first skill is I want to show that you don't have to differentiate y and x. So I've got A in terms of r, and I've got the area of a circle. A equals pi r squared, and I'm going to differentiate that, and I'm going to differentiate the area of the circle by the radius, or with respect to the radius. So I've got dA by dr, so that means my method that I use for differentiation applies to the r's. So my method, remember, is multiply by the power, subtract 1 from the power. So where in the past I've had numbers, I've now got a pi. That's the same, so that goes in, nothing to do with r. I multiply by the power of r. Power of r is 2, so that's 2. I take 1 away from the power of r. 2 take away 1 is 1, so that's r to the power of 1, which is r. So the differentiation of the area of a circle actually is the circumference of the circle, which is quite cool. The second skill I want to focus on is these, because of my formula here I've got 3 parts, and remember the sign goes with the bit that follows it, and the middle part of those is easy. So let's do that bit first. So I'm going to this time use a different notation to show I'm differentiating. I'm going to use y dash. Sorry about that. Oh, I've forgotten something. I need to rewrite this as powers of x in a straight line. None of this roots or fractional part, so I need to rewrite that. So let's think about that. The square root of x is the same from the algebra section we did earlier on in the year as x to the power of a half. The middle bit is 3x squared because that hasn't changed. And remember, if I've got a fractional in power, or if I've got an x in a fraction, then I can invert that and get the x on the top, but to do that I have to make the power negative. Now I can differentiate that because I'm going to differentiate this. So I'm going to multiply by the power, so I get a half. I'm going to subtract 1 from the power. X to the power of, well, half minus 1 is minus a half. I'm going to multiply by the power, so that's 6x, and 2 minus 1 is 1, so that's 6x. I'm going to multiply by the power, so that is plus 16. I'm going to subtract 1 from the power. X to the minus 2 subtract 1 is x to the minus 3. So now, once I differentiate that, I've got 1/2. I now need to deal with this fractional bit. The fractional bit means that it's the negative means it's a fractional part, so the x is now on the bottom, and the half means it's a square root. That's not very clear. Let me just erase that and try writing that again. So that's the square root of x. The plus 6x hasn't changed, plus 16 over, now the fractional bit, again the negative means it's on the bottom, and the power is 3. So there you go. When I differentiated x or square root of x, I got a half square root of x, but the square root of x is now on the bottom. When I differentiated 3x squared, I get 6x, and when I differentiate minus 8x squared as a fraction, I get 16x cubed.